So basically, your phone percentage is lying to you, as is your
Ah,
laptop and your car, and all these things that have batteries are kind of making it up. So when an EV catches on fire, it's like national headlines. When a gas car catches on fire, it's just Tuesday. The sales pitch for EVs, I think it's been all wrong.
you're running a business, you're in your undergrad, you're building all of this. How do you do it? Welcome, everyone. Today I'm sitting down with Reider McFeely. And Ryder, you are with Vero BMS, correct? Vero
Yep.
Electric.
Yeah.
Now, I asked Ryder how does he typically introduce himself, and it turns out he's a rather humble dude. He says, "Well, I'm the guy behind Vero," but Ryder, you are way more than just the guy, right? You're the founder and one of the owners of Vero Electric.
Yeah. So I started it a couple years ago, and for about a year and a half, it was just me, doing all the hardware and firmware. Pretty quickly, I realized I'm not all that great at the firmware, the coding side, and so brought on a couple guys for the software stuff, which were much better than me, and have some also bring some cool ideas to the table. So now it's a team of four of us.
That's so cool. I have really enjoyed looking through some of the projects that you guys have, and we're going to talk more about that as we get deeper into it. But I understand that your first introduction to EVs in general was actually a conversion that you did on 2010. Was it a Ford Explorer? Is that right?
The Ford Escape,
Ford
yeah,
Escape.
yeah. So not as fancy as the usual conversion candidates, but it was cheap. It was 2010 Ford Escape with 156,000 miles on it. It was a five-speed, which is surprising that Ford even made that, but it was their absolute bottom trim. And so that five-speed made it easy to convert because you could just get a Hyper 9 motor with an adapter plate and slap that motor on, get some batteries, and you're pretty much on your way. And that's what I did.
Was it harder than you thought it was going to be?
I would say the electrical was easier than I thought, and the mechanical was a hell of a lot harder. Just building all the battery boxes, making it all fit, drilling holes for this, that, and the other thing. It's a lot. It's tedious, and you want to make sure that it all holds up. Whereas the electrical, you can fit your entire schematic on a single page of a document. So it's really not that bad on the electrical side. And I might be a little biased speaking as an electrical engineer, but I think the mechanical engineering side of the EV conversion stuff is tougher. So
So being an electrical engineer helps.
definitely, I think so. I think so. Yeah. I think probably the best skill you could have for an EV conversion though is just fabrication skills. Like if you know how to weld or if you have CNC equipment, you're ahead of the pack for sure because there's so much fabrication you have to do for any conversion. And so that's why I think some of those kits are so popular, like the EV West, where they've got the battery boxes and the mounts, and the motor
Sure.
mounts and all that stuff pre-made.
So, had you had any experience before this build in doing a custom car at all, whether it's like tuning your daily driver or modifying it or even a full build?
No, nothing. This was in high school. I actually started this project before I even could drive. So zero experience with anything gas or electric. I was always thought Tesla was cool, and I'd been like a car guy for a while, but I'd never really done any tinkering myself. So this was my first time, like even draining the oil when I was taking out the engine. First time doing anything even at that level. So learned a lot,
I
a
love
lot.
that. But an EV
Mm.
conversion is kind of like a head first sort of thing. What got you excited enough to dive into that?
Well, I've always been kind of a tinkerer. I guess started building computers, I think when I was 10 or 11. And I was really into that kind of stuff, which was cool. And then I feel like the logical next step for that is, when you're a kid, you're playing games and stuff like
Yeah.
that. So you want a computer. When you get a little more grown up, you want to go places, you want a car, right? And so I
Yeah.
wanted to I wanted to build my own car. And really, I think the reason for that is I wanted to understand how my own car worked because I just like understanding how things work. And so getting into something every day and having no clue how it would get me from point A to point B sounds kind of lame. So I wanted to really understand how it worked. And I think the best way to do that is to tear out all the gas stuff from a car and put in electric stuff. And then you can say this does exactly that, et cetera.
How long did that project take you?
It was like 2 years,
Okay.
2 years mostly on weekends. It was a process, but
That's still pretty good. I've
mhm.
seen projects that take a lot longer than that. So, I mean, 2 years is still within the realm. I'd say.
Yeah. I was putting in a lot of hours, and I mean, a lot of it I was starting from basically zero. I mean, I didn't know what a volt was, what an amp was. It really was starting from nothing on that project. So a lot of it was just learning the very basics, and especially the safety stuff and the fabrication stuff. I had never welded before or any of that. So it was definitely a process.
Would you credit this build as being something that tipped you over into now being, studying and being an electrical engineer?
Definitely, yeah. Well, actually, it was also a kickstarted Vero Electric.
Okay.
So in my build, I used the Hyper 9 motor and then 10 Tesla modules out of a Model X. I think it was a 2017 model year. And I was using the SynthBMS, which was an open source, it was closed source hardware, but an open source firmware developed by Tom Dupree over in the UK. He's a really good guy. And there wasn't really anyone selling that in the US. So Vero Electric at the beginning was just importing that product from Tom and reselling it to US customers and providing support and setup help and all that. And then I realized that, I thought there was a bigger opportunity for all of this reuse of old EV module stuff. And the SynthBMS was a great product, but it required some pretty substantial know-how technically to get
Hmm.
up to speed on. And so my thought was, why not just make a lot of the tedious and unintuitive stuff as simple as possible? And so that's kind of where the Vero BMS and especially the V2 came from. It's like a smooth UI, plug and play, like harnesses the modules, all that kind of stuff. That just makes your life easy.
So this might be a silly question, but what does Vero mean?
So it means it's the truth in Latin, like veritas uh,
Oh,
is
I
like a
love that.
prefix. So true
Yeah.
electric is kind of the basis of that. Yeah.
Awesome. And so you took the SimPMS, you figured, all right, we can make the implementation of this a lot easier than than it is currently, and launched the company. And now is what you primarily create BMS systems?
Yeah. So we branched out from just the BMS to create kind of an ecosystem around it. So we also have a remote monitoring product. And now we don't just work with, second life EV batteries because we have our Vero BMS node, which can work with any lithium battery. But it's still centered around the core Vero BMS V2 as like the central product.
Okay. Interesting. And so it has branched out quite a lot. And these are getting built and used in a lot of different types of conversions, right?
Yeah, so we see our breakdown is now it's less EV conversion than solar storage, just because solar storage has really taken off.
Hmm.
It's like everyone and their mother wants to have a battery backup these days. That's probably about 60% of what we see. But on the EV conversion side, yeah, I mean it's everything. Like the classic cars is a big part of that for sure. The old Porsches and VW Bugs and all that kind of stuff, which is always cool to see. But then also some interesting ones, like a forklift. We worked with a lumber yard, which had a bunch of old propane forklifts with blown motors, and they put in actually Hyper 9 motor and some Tesla modules, and now they're running a couple forklifts on electric, and it's saving them the money on, just on the fuel, but also on maintenance because with those lifts you would need an oil change every couple months, plus an engine rebuild every couple of years. So especially over time, it turns out to be a very logical route to go down. And there's some other cool ones too, like some movies and stuff, which I'm not really allowed to talk about at depth. But yeah, lots of cool projects on the EV side for sure.
That's awesome. So maybe talk a little bit about a couple of the builds that you can mention, and for people maybe just tuning in, some of the primary, like most important things that a BMS does.
Sure, yeah. I'll start with, and I think I sent you some pictures from this, but Chris Johnson in New Jersey, he's got a Fox body Mustang that he
Sweet.
has 16 Tesla modules in and a Tesla drive unit. And so that's all running our system. He takes us to shows and stuff. That was a really cool build. What was the other part of the question?
Well, just like, what are the kind of the high level BMS battery
Oh yeah,
management system
right. Yeah.
for
So
someone like Chris with that Mustang? What is this BMS doing?
yeah, so most crucially is safety. That's like your number one above all else. You have to make sure that things are operating safely. And so that might mean, shutting things down early if say one cell is out of voltage. So if you have, and this is what's called balance, if your pack is balanced or not from the perspective of BMS. So if you have one battery cell out of in a typical Tesla 96 in series, If you have just one battery cell that's out of range, that means you have to shut off the whole pack from a safety perspective.
Yeah.
And the reason why the BMS does that, not the inverter or any other, your drive unit, is because the inverter or drive unit can't tell. It only sees the pack voltage, and so it can't tell if it's just one cell that has a weakness, or is overcharged. And so that's where the BMS comes in by reading every single cell voltage, checking all those, making sure they're all okay before allowing any operation, whether that's charge or discharge. And then it's the same thing with temperatures, right? So if any single temperature sensor is out of range, shut that off immediately. Shut off the pack immediately to make sure things keep operating in a safe range. So that's the safety component. That's like the number one goal that trumps everything else for sure. But then also another big one is calculating your state of charge.
Okay.
And so people think that state of charge, like your battery percentage, is just some inherent number that your battery pack spits out. But that's not at all the case. It's actually it's an algorithm, completely algorithmically driven, and there's a lot of almost guesstimations done. And so you can kind of think of on your iPhone, when you charge up to 100%, you might realize that as you unplug it and start using it, it kind of sits at 100% for a while. And that's because the battery management system on your iPhone is programmed in line with human psychology to just sit at 100% for a while to make it feel like the phone's battery really has a long life. And then it'll start dropping, fairly quickly after that. So there's an element of almost like deception for some state of charge algorithms. We
Yeah.
don't do that in ours because our customers want to know the true state of charge, not hide the values. But it's very algorithmic. And same thing for state of health. There's tons and tons of parameters that go into calculating those things correctly. And it's kind of an ever evolving game with all the different battery chemistries and configurations that we see.
That's really interesting. So some there's some kind of percent, say, on a phone where it's not really, they're manipulating the readout to make it seem like it's not discharging. And that's what, like, I've noticed it doesn't seem to be a smooth discharge curve on some of my electronics, where it'll
Mhm.
be, stays at 100 for a while, then it drops down, and then, there might be another plateau somewhere, and then that last 10% really goes fast, and then
Right.
it stays at like 1% for a weirdly long time.
Mhm.
And that's not necessarily the battery characteristics, it's just the software and the way they're displaying it.
Exactly. Yeah. And so internally they'll know what they believe to be the true percentage, or at least they'll have an estimate, and then they'll offset that, based on user characteristics, what they believe the user wants to see. So basically your phone percentage is lying to you, as is your
Ah,
laptop and your car, and all these things that have batteries are kind of making it up or fooling you at least. So
I've talked to guys who in their conversions they don't have a battery state of charge. They just watch the cell voltage and they use that as their kind of, it's somewhat of a guessometer. Is that how you have your Ford Escape? You still drive that, right?
no, yeah, we have RBMS in there.
Oh,
I've
you
got
have
all of
that
our in there.
percentage on
Yeah,
the
yeah,
display and
yeah,
everything.
yeah.
Cool.
I've got percentage, and with Vero Go, I've got remote monitoring. So I've got like a phone app I can check it out on
Oh, that's
uh,
cool.
location percentage. I get email alerts if anything goes awry, which means I don't get email alerts often, but if something goes wrong, I'll get a message. So yeah, we're fully protected on that front.
Sweet. What other notable builds would be good to kind of illustrate the breadth of applications for your BMS?
Let's say, well, a good one recently actually is Linus Tech Tips. There's a big YouTube channel based out of Canada that does just kind of tech reviews and stuff. They put together kind of a prototype home battery backup using Tesla modules. I think they just used 4 modules, and they used our system. And so that's kind of the other end of what we do outside of the EV stuff is a lot of this home battery backups, because when you're looking to power your home in the event of a power outage, or if you're running fully off grid in, say Western, Montana or whatever, you need some way to store that power in batteries. And you kind of have two options. You can go with like the nice OEM route, which is good equipment, no doubt, but it costs, $500 or $600 a kilowatt hour. In the case of the Tesla Powerwall, which is Tesla's off the shelf solution, it's almost $1,000 a kilowatt hour. Whereas if you're using old EV batteries plus our system, you're at often sub $100 a kilowatt hour. So it's a huge cost difference. Plus expandability. A lot of these OEM systems are super limited on how many batteries you can put in before you have to get funky with all kinds of tie-ins on like the panel side. Yeah, like there's limits to how much you can stack often with these kind of easy off the shelf solutions, and so you're limited. Often it's less than 100 kilowatt hours, which is fine for most houses. But as you know, 100 kilowatt hours that's only on the larger side of one EV battery pack, so it's not a huge amount. And so if we're dealing with like we have a couple customers on farms that need to power their whole farm off solar, like 100 kilowatt hours is not going to fly.
Yeah.
Or customers, some other cool ones, some folks overseas in Nigeria. Nigeria's grid is not reliable. They have rolling blackouts, brownouts all the time, and so they don't even have solar. What these guys are running is just a battery pack that charges when the grid's online, and then for the 5 or 10% of the time the grid's offline or when the power is reduced, they're running everything off the battery pack. And so it's kind of another clever use of batteries that when I got into this I didn't really think of, but it's cool seeing all these other applications.
Yeah, it really is. I think that it's pretty sweet that electric cars and solar and batteries, it all kind of like there's a lot of overlap between them. And I mean, talk about independence and freedom from the gas pump. Like you get so much flexibility to just do what it is you want to do and not have to worry about whether the grid is up or the pumps are working. And that kind of appeals to me as well.
Totally. Yeah, I mean, I think the sales pitch for EVs, I think it's been all wrong, in my opinion. At least the whole angle that is for the environment, I don't buy into super strongly because there's still a whole lot that goes into making an electric car, and so it's not like an environmental slam dunk by any means. But there's been a complete lack of focus on the things that I think actually make EVs really great is the power independence and quiet, smooth, reliable operation. And I think those are like a no-brainer
Yeah.
objectively, with the exception of if you like, the sound of a rowdy V8, which I understand. I like those too. But there's so many other selling points for EVs that people just don't talk about. Like one of the best things with EVs is that you can run it on any fuel source. You
Right.
can just have a generator, and if you have gas, you'll be charging your EV. But good luck fueling up your gas car if all you've got is electricity, right? that's
Totally.
that's beyond our current scientific understanding, at least to my knowledge. So yeah, I think it's just objectively the future of transit because it's so much more flexible. And from like the noise perspective, an EV you start off with no noise, whereas gas cars they've been trying to make them quiet for 100 and change years now. And I mean, they're quieter, but they're still not nearly as quiet as any electric car, right? So it just seems to be the logical next step for transportation in my mind.
Yeah. And I mean, for people who really do like the sound, I gotta say, I've driven some track EVs and like you can hear them. Like there's a
Mhm.
howl, and whether it is hearing the suspension and the tires as you're like on the edge of traction and you're taking the curve as fast as you can, or even the gears of your single speed transmission, you can absolutely hear the motors when they're being pushed really hard, and it's kind of like a futuristic type of a sound. It's not a V8, but it
Right.
does sound pretty mean.
Totally. Yeah, there's a lot of sound options for EVs. Again, when you're starting with no sound, it's a lot easier to add sound in than to take it out. And so I'm not huge on the fake sound thing.
Nah,
I
me
think it's
neither.
a little it's fake. It doesn't fool me. Like I know Dodge does that with their electric Hellcat, which I saw at CES, which is pretty cool. But but there are ways to do it that aren't really faking it. And so a cool one that I found in my car is the Hyper 9 motor at specific frequencies or at specific RPMs will emit frequencies that interfere with AM radio. And so I
Huh.
can tune it to specific AM frequencies. It's like 670 or 680, and I get what sounds like a spaceship taking off over
Yeah.
the speakers, which is absolutely incredible. And that's a true sound. That's actually, you're changing currents within the motor's wiring, inducing a current on your antenna. which causes that sound output. So that's very real. That's not faked at all. And I think that's what EV manufacturers should be doing. Taking that real electronic noise essentially and harnessing that to make your engine sounds or your motor sounds.
Yeah. Yeah, there's a lot of cool stuff in there. What do you think is going to be the next, say, 5 years in EV conversions, or even just like electric cars in general, or the interplay between the two? Because your BMSs are able to use a lot of the different batteries that are now on the market, right?
Right. Yeah. Well, I think I'll start with the EV conversions because I think or the electric cars. I think the EV conversion stuff kind of follows, what the electric car market is doing. I mean, we've seen it's the growth has slowed down recently, but I think that's really just because manufacturers weren't able to get price parity between gas and electric models. And so when you're a customer deciding between the 35,000 gas model and the $45,000 electric model, you don't see those payoffs right away. And so, okay, maybe it'll be break even in 10 years, but that's not really compelling when you're at the dealership. So I think the costs need to come down, and they are. And I think once they get there, that's when we'll really start seeing all of the numbers really shift from gas to electric. And so I still think it's just a matter of time, essentially, because there's so many advantages, and as charging continues to get more and more built out. I mean, I've seen it happen myself, taking the same route up from Maryland to Pennsylvania up to New Hampshire. Every year I go up, there's more and more chargers, and it's
Yeah.
easier and easier. The first year I did it was not easy because the Electrify America stations didn't work, some of them, and EVgo was charging ridiculous prices, which they like to do. But now Tesla superchargers, a lot of them are open, and it's just getting brighter and brighter for EVs. So and then a lot of this growth will trickle down to the EV conversion stuff because it's just an increase in the supply of vehicles that are going to hit the second life market, with crashes or end of life packs or whatever. And so I think that'll drive prices down, which will help, and it'll also make it more compelling for companies to build this kind of stuff that make EV conversions doable, right? So like the battery management stuff, yes, but also the inverter controllers for drive units, all that kind of stuff. I think the demand for that will go up, and that'll make prices go down in time as supply ramps also.
Yeah, I love that. We want more and cheaper parts for sure.
Yeah.
So we talked a little bit about EVs and about battery backups for houses, but is there other applications that you are seeing your BMS being used on?
There are a few. Yeah, we see all kinds of stuff. So
Out of the box stuff.
one that's not so out of the box is repair shops. Like Tesla third party repair shops where they want to fix the BMS fault codes that some of the the Model S's have in the earlier model years. So those they just take our system, they open up the pack, plug into all the modules, note that okay, X module has a bad cell. Cell 3 and X module is bad. let's pull out this whole pack. Maybe we can sell this pack and then put a new pack in. Sell the pack minus the bad module. So it helps with that kind of stuff. Some other cool ones we
Oh,
saw is
wow. So wait,
yeah.
so
Mhm.
your BMS is able to diagnose pack issues better than the OEM software?
So I wouldn't say better. I will say cheaper because
Cheaper. Okay.
The Tesla toolkit is very expensive. I can't remember exactly how much. And this isn't a ton of our customers doing this, but it's at least a
But it's
handful of them.
possible. Yeah.
It
Cool.
is possible. And so especially for the shops that are not full Tesla shops, that they're doing all kinds of other stuff too, it gives them the flexibility to at least dip their hands into it as long as they've got the the high voltage training. Because a lot of it is not really rocket science. You can see pretty quickly, and the same thing that trigger the Tesla fault codes like the BMS U019 and those ones of that nature. It's just most of the time it's because one cell is way out of voltage range. And so you can plug in our BMS and right away see that there's this cell lagging or this cell is overcharged or whatever, and that's a very quick diagnosis that saves you the making up numbers here, but 10,000 upfront plus 1,000 a year or whatever for the Tesla toolkit.
Yeah. Okay.
Yeah, and then some other ones there were some autonomous submarines that were running Tesla modules. I can't remember what depths they were going to, but that was running RBM Tesla modules. I think for I want to say it was for like some kind of disaster relief or something. I can't really remember. But yeah, tons of kind of funky applications.
That's really cool. It it is a good reminder that there's so many applications for motors and batteries, even beyond automotive and battery backup, which is where I think a lot of us spend most of our mental bandwidth thinking
Mm,
about.
yeah.
Back to the cars though. So do you personally have any builds that you are eyeing when you have more time or redoing the Escape?
Yeah, at some point I'd like to beef up the Escape. I think the Hyper 9 is a little underpowered for it
Yeah.
because I think we're pushing with 10 modules in the Hyper 9, pushing like 4,000 pounds. And it's not, it's 120 peak horsepower, passively cooled. It's honestly, it's undersized. And so it overheats. Sometimes I'll get, heat warnings on it if I'm pushing it for a while. So I think really, yeah, I need to step that up or really just cool it. Because that's the big limitation with the Hyper 9 is that because you're relying on air cooling, just through the body of the motor, you're not gonna be able to push it real hard, even if you have decent airflow, because your heat exchange rate is just not going to be very good compared to a radiator that's got all kinds of surface area, you know.
Yeah.
So, and I want to say there was a company I saw doing this, but if there was some way to, bolt off the end plate and put on an end plate that has coolant channels, then I could run it to a radiator, and it would be a much better outcome than just having the motor thermal throttle itself
We're doing
after.
that on the race truck, the
Oh,
Arc
are you?
Blast race truck. There's Tyler that he ended up finding a Hyper 9 in Europe, but it's a water cooled Hyper 9. So it has a jacket on the outside of the motor body, but we're still running into heat issues on the track.
Oh, really? What's your radiator setup?
It's in the front, like how
So
big it
big.
is. It's not cooled with like a AC system or anything like that. It's just air to
Right, right.
water heat exchanger radiator that then flows through the Hyper 9.
Yeah. Yeah, usually that's enough because the motors are more than happy to run all day at, 60 or 70 degrees Celsius.
We're
It's
just
just when
pushing it at the
you're right,
track
right, right. Yeah.
and running 24 hours at a time.
Well, 24 hours. At those time frames, you can't be too you can't be too disappointed if it's like
Nope,
this long.
we demand more.
Yeah, right. Right.
But that exists. It is a gold coolant jacket. So that is, and as despite it getting hot and the
Gold
batteries
isn't
getting hot and
gold the
all of the,
material.
what's that?
Gold isn't like gold the element, is that what you
No, it's just colored gold. So,
said?
but that's how,
Okay.
if you look at the Hyper 9 motor, it has this like gold jacket on the outside that it's like, oh, that looks different than any other that I've seen. And it's because
Right.
it's a water cooled version.
Yeah. Does it, I guess, were you trying to push the, like the amp limits as well
I
with that
think
one?
we have at one point or another pushed just about every limit.
Yeah,
That would be a good one to talk to some of the engineers on the team about. If you're interested, we could definitely have a deeper conversation and kind of what they've tried and where they run into cuts. We have a custom pack with iPace modules in it, and we have one thing or another have hit roadblocks on all the different components and then fixed it and been
hmm
able to turn up the heat and then hit another roadblock. But super fun truck to drive. And
Yeah, I'd love
it's
to talk to those guys.
yeah. Oh,
The iPace, that's what Waymo uses for all their self-driving cars now.
oh, wow. Okay, sweet. Well, yeah, we should have an offline discussion with that team because there's just a few of us that are doing this that are on it's Team Arc Blast, and we race that truck at endurance races and do some fun stuff.
For sure.
Sweet. But back to what we're focused on today. I guess we've covered a lot here and more on a personal level. How do you keep motivated? It's kind of been implied here, but you're still in school. You're in masters now, right? Or
No,
PhD?
I'm actually undergrad.
Undergrad. Oh my
Yeah.
gosh. So
Um,
you're running a business, you're in your undergrad, you're building all of this. Like how do you do it?
well, I think I just like being busy. I think that's a big part of it for me. I hate having free time, genuinely. And so and I really enjoy doing this kind of stuff. Like seeing all the customer build photos come in when I reached out to all those folks. It's super rewarding to me to see the system that I engineered, our team engineered. out there in the real world doing real world things on real world projects. And so it's really exciting to see that stuff. And so it doesn't feel like work to me. It more just feels like play, you know.
Yeah.
It's fun. It's fun seeing this kind of stuff and being in this space, especially at this time, you know.
Well, I think that you've hit on something. If you can capture that feeling of excitement and use that as a motivation, like that's kind of the dream, what we're all striving for. Maybe can we dig a little bit deeper into batteries and technology? Um,
Sure.
what's one misconception that you have kind of come across that people have around either building their own EV or building a pack for whatever their end use might be?
Mhm.
What do you have to tell them and remind them most often?
Well, I think one for building your own EV is people that don't really know, that aren't experienced with EVs really, or gas car, you know, or the intricacies of gas cars versus EVs at all. They kind of assume that when you take out the engine and convert it to electric, the car gets a lot lighter. That's almost never the case because of the batteries. Like, yes, you are losing weight going from a gas engine to a electric motor almost always, but the batteries are still such a huge component weight wise that
Mm,
you're not seeing a net weight reduction. And the other big one is that kind of like what I was talking about earlier, it's really more on the mechanical side than the electrical because the core electrical connections are pretty simple. There's a lot of them, but they're not, they're very standardized, I would say, from project to project, right? And so that's why companies can put out these wiring schematics or diagrams that apply to all their setups because that doesn't change whether you're converting a 78 Mustang or a 83 Beetle or whatever. What does change is all the fabrication stuff. And so that's where you have to get creative a lot of times, just making the batteries fit in a way that's safe, in a way that you're confident in, and then running the wires within that. So the actual connections are not hard, but making them physically can be.
now, kind of thinking about your design and how do you get to that schematics? How do you get to that, the instructions that people can then implement within their builds and their end use? What are some of the hardest challenges from an engineering perspective across your product line?
So for us building them or for customers integrating them,
I think for you guys building them and developing them.
yeah, so building them, one of our big challenges was we now have the Vero Go, which is our remote monitoring accessory for the BMS. So that pumps your critical BMS data to the cloud, plus location data if you choose to have it. And then you can view that from anywhere in the world and get alerts. And we're about to
That's
release
cool.
an update with bidirectional capabilities, so you can schedule a charge and also set your charge and discharge limits on the fly, which will be big. But getting the GPS in particular working was tough because GPS for receiving signals from your satellite array, the signals are pretty weak, right? Because you're coming from satellites that are many miles above, and so you need to have a very specific, very very controlled PCB design in order to receive those signals. And so what that takes the form of is what's called impedance matching. And so you have to run your traces, so your wires essentially on the circuit board in such a way that the impedance, which is like the AC equivalent of resistance effectively, is matched at exactly 50 ohms to some pretty high precision in order to receive those signals correctly. And so that takes some lab testing and quite a bit of back and forth with our suppliers and revisions on the board just to get that working reliably so that the GPS is precise and can pick up signals even if even if there's some level of obstruction. You think like a tree cover, or yeah, you're driving through, yeah, a wooded area. So that was challenging, and then also getting all that data to the cloud securely and to the end user securely in a way that we are very confident in. Took a while to get right. And we're there now, but it did end up taking about twice as long as we were hoping it would for the whole project.
Wow.
It worked out. So
Some detailed work. Have you run into any headwinds as far as the regulatory environment? I think in the US, we tend to have we're pretty lucky compared to like Europe when it comes to EV conversions. But I know that battery backup, it's really state by state, region by region. And sometimes agreements with power companies can be a challenge for folks, even when you're using a established installer rather than a DIY. Have you had
Right.
clients asking you about this stuff or any
Yeah, yeah.
experiences
We get
in
compliance
working through
questions
it?
all the time. I would say, like you said, it's definitely more in Europe.
Okay.
You've got the CE cert, which is a very involved process over there. But in the US, we have FCC. So like anything that's working with radio waves in any way needs to get certified. And so that's why we use a pre-certified module within our Vero Go, which means we don't have to perform the same testing independently because we're not transmitting anything on those waves that could interfere with critical signals. And then for the home battery backup stuff, yeah, it's in the US is 100% crapshoot. I mean, it varies so much. So like the NEC, the National Electric Code, has standards, but not all locations adhere to those same standards. Some of them have modifications to them, right? Or additional standards. And there really is no one size fits all regulatory requirement for this stuff. And so I think that stuff will shake out in time. But right now it is still a little bit of the Wild West. And so people are doing all kinds of things, which for the most part, we do our part to keep things safe. But ultimately, once our device gets in the end user's hands, it's up to them to actually assemble the system properly. And so we give you everything you need to do that. But there's not always a check there after things are all put together that everything will be safe and reliable long term. And so I think that'll come around eventually.
Do you think that the DIY solar battery backups for like a house, is it getting close to the maturity where someone like me would be able to figure it out?
It's getting there. I mean, I would say, I never recommend people that don't have electrical experience take this on just because the risk is high, right? It's the same thing as working with your home wiring. Like, yes, if you know what you're doing and your local codes permit working on your own electrical, you go ahead and do it. But the risk is pretty high if you're not 100% confident, right? Like electrocution's no joke, fire's no joke. All those things are very legitimate. So I always just recommend caution, or at least having some way to mitigate that. And so like if you're off grid 10 miles from anyone else and you can build a shed that's 100 feet away from anything, then go wild, right? But for most people that do have neighbors that they can, if they yell, maybe your neighbors will hear them within that kind of proximity. Then I would definitely 100% do it the kosher way. Go through all the checks, check with your local safety inspectors, and if in a lot of cases you're not even allowed to do your own electrical, like here in Philadelphia, all electrical work has to be contracted out.
Oh, really?
Mhm.
Well, I mean I can switch outlets and stuff like that,
Mhm.
but if I was to do an EV conversion, I would need someone to help me on on a lot of the electrical stuff. And I know a variety of different builders and shops that would be able to do that. Are you seeing the similar thing in the the DIY solar packs as well? Because you said at the front end that so going for someone like Tesla is $1,000 a kilowatt hour backup, but it's if you were to do DIY it, it's probably more like 100 or 200. And even if there's a premium bringing in someone to help you, that's still wildly more accessible for a lot of people. Is that
Right.
community, is it formed? Are there people that I could call?
Yeah, it's still early stages. So we work with a handful of solar installer, battery installer companies that do that. But the vast majority are still, I think, just because they're not aware of the opportunity. And obviously, second life EV batteries aren't a perfect fit for every scenario. But there are a lot of scenarios where they are an appropriate fit. And so I think it's just getting the word out about them and then really emphasizing the cost difference. And so I think
Yeah.
I think that'll come around, but it needs time.
What's the top one thing that would make them not a good fit? The Second Life EV batteries would be not a good fit for home battery backup.
So the big one is just chemistry based. So a lot of EV batteries are NMC chemistry, and so this chemistry is when operated properly is perfectly safe. But if not operated properly, there is a risk of what's called thermal runaway,
Right.
where essentially the battery will heat up and then just keep heating up without an external heat source. And so that can happen if you overcharge your batteries, which our BMS prevents. Prevents, but only if you have a contactor that physically shut things off, which
Mm.
our BMS will all do automatically. But ultimately, that responsibility falls to whoever is installing your system. And obviously, overcharging can also happen with other cell chemistries, like the one that we see a lot for home battery backups now is lithium iron phosphate, which this one, when you overcharge it, doesn't tend to exhibit the same thermal runaway properties. It's not as reactive of a chemistry. And so that one's been popular for home batteries, especially when it's like within the home or attached. And so there are some EVs that run these chemistries more and more now as LFP costs have come down, but they're still not the power to weight and energy to weight hasn't matched NMC yet, which is why all of the all of the top end EVs or even mid level EVs are still running NMC chemistries. And so that would be the one of the reasons why most battery and cells are using the off the shelf type things, because they tend to be LFP, whereas EV batteries are just starting to turn towards LFP.
Got it. With the Tesla power walls, those are NMC, right? Because they're reusing Tesla cells.
So those. I think now some of them are LFP. I would have to check
Okay.
on that. For a long time, the Tesla Powerwalls, the early gen Tesla Powerwalls, were literally two Tesla modules from an EV, because they use that module design for a lot of their stationary storage, grid scale stuff.
Got it.
So it was a standardized module design for them for a long time. And so yeah, they were using a lot of NMC cells in those, and those have largely held up fine. And so it really does come down to management, right? As long as you're safely managing them, incidents are exceedingly rare. Just like you think about EV versus gas car fires. I mean, when an EV catches on fire, it's like national headlines. When a gas car catches on fire, it's just Tuesday, you know?
Yeah. And it almost never
Um,
happens for EVs.
right, right. And so, obviously with a lithium battery that can sustain itself uh, for a fire, it's a grave safety concern. But just the incidence rate is so much lower, that at least Tesla and the like have felt comfortable deploying NMC cells all over. And it's worth keeping in mind also that your phone and your laptop and all your personal electronics, those all run largely NMC chemistry cells, or similar fairly reactive chemistries. Just because LFP energy and power density is not compelling yet for especially those size devices.
Really in the weeds as far as the software that is in a BMS as it pertains to protecting a cell from overcharging or something, some other event. How
Mm.
does that work from like a redundancy or like fail safe mechanism? Because I use applications all the time that work great like 99 out of 1,000 times, but then one time it crashes. And in a computer, you just like force quit it and retry again. It's not a big deal. But for something that is like a system critical application, like the software running a BMS, there must be a different way that you approach it.
Right. Yeah. So it's essentially what's called intrinsically safe, where it fails in a safe manner. Okay. So if everything goes to shit and you lose power to your BMS and everything goes offline, the BMS will by nature, because it's no longer supplied power, cut all power to outputs, which means if you've configured your system properly, that the battery pack is now isolated from any chargers or loads. And so that's kind of the inherent fail-safe mechanism, where if everything goes wrong, you'll be in a state where the pack is just simply sitting disconnected, which is considered the safest state to be in.
Yeah, that makes sense.
Yeah.
Another question I had for you while we're on the topic of chemistries is do you have any insight on solid state batteries?
That's a favorite question. I'll say that they've been 5 years away for 20 years now.
Right, it's
So
got to be soon, right?
right. I'm skeptical that well, I think I'm skeptical of two things. One, that it'll be that huge of a difference. I think the data we're seeing now is that it's not. I mean, it is a substantial, non-trivial increase in energy density, and I think to a lesser extent also in power density, but not like the huge night and day order of magnitude type difference that I think was at one point touted. And then also I think it's just ramping production for things of this nature, like battery cells, takes quite a few years, and I think the ramp hasn't really even started yet to any substantial extent. So I think we're still a ways away from seeing large scale solid state batteries out in the wild. I'm sure we'll get there, but I don't think it'll be as groundbreaking or as quickly as people seem to think.
Do you think maybe it will end up in kind of flagship products first, where the cost premium and performance weight benefits are most substantial?
Definitely. Yeah. I mean, like with most new tech, it'll kind of work its way down. So yeah, it'll start off at your Halo cars and then eventually end up in your computers, you know. But I think we're really not even seeing it in the Halo cars yet. So
No,
it's a ways off.
just 3 to 5 years.
Yeah, well, 3 to 5 years is a decently long time, but it has been 3 to 5 years for 20 years.
I've noticed that too.
Yeah.
Hypothetically, though, they would still need battery management, right?
Oh, absolutely. I mean, so the battery management application remains almost the same, and so the chemistry would be a little different. The limits would be a little different. Your algorithms would need to be modified a little bit to fit the new cell type, but otherwise, it's exactly the same as it once was, because those batteries still need to be managed properly, efficiently, effectively in order to keep things running smoothly.
Another thing you briefly mentioned to me that I'd never really heard much about, and so want to put you on the spot to dig in a little bit more deeply to, is wireless battery management. What can you
Mhm.
tell us about that?
Yeah, so there's a handful of the battery management chip manufacturers, think like Analog Devices or Texas Instruments, have these wireless BMS chipsets where each module will have a chip on it that reads all your cell voltages and temperatures and then reports back to the pack controller. And so traditionally that link has been through wires, usually CAN bus, which is kind of like the automotive standard communication protocol, or UART serial, or what's called ISO-SPI, which is a technology that Analog Devices uses. It's proprietary version of standard like serial peripheral. But there has been somewhat of a push recently to move to wireless for that connection. And so the idea there is that you can just simplify the assembly process because that's one less harness you need. There's one less harness you need to make, one less harness you need to test, and one less harness that could be, you know, installed incorrectly. So it eliminates one point of failure, but in my mind, it also introduces some other points of failure that are more concerning. I'll say that you'll find that a lot of electrical engineers will always go for wired over wireless for a lot of things, headphones, charging, etc. Just because a wire is intrinsically much more reliable than wireless charging or than wireless. And so, like for the charging example, wireless charging, your best case efficiency is not very high, whereas wired charging, excluding your power transformation losses, is almost 100%, right? Because those wires don't add a whole lot of resistance to the system. And so same goes for wireless BMS. That in theory, I think it makes a lot of sense because it cuts down your bill of materials for these manufacturers, which are desperate to get costs down for EVs. But then it also introduces a really serious failure point in that you could lose communication if, say, you're operating in a very noisy electrical environment. And so in theory, that would also affect wires, but your threshold there is much higher to get to a point where interference makes a difference. And for some communication standards, wired communication standards, there's a lot of inherent fault tolerance built in. So like CAN bus, and this is getting pretty into the technical weeds, but CAN bus was called a differential signal. And so all it measures is the voltage difference between your two wires, your CAN high and CAN low. And so that means if there's some electrical noise that's interfering with them, as long as they interfere with both wires, the the receiving device will be able to filter that out because it'll still see that same voltage difference. And so with wireless, you just have a lot more that can go wrong, and the threshold for interference is just much lower. And so I know GM with their Ultium packs is running those on a wireless BMS system, and I've heard that the failure rates on those have been pretty high, specifically in regards to the wireless BMS. So I'm just skeptical that trade-off is worth it. You know, the cost saving on the manufacturing side versus the long-term the long-term ramifications for performance and longevity for pack and even just operation. Because if your pack loses communication, if your controller loses communication with the modules, that's a complete fault state, like a blocking fault state for your car. And so you're not going to be able to drive it. You're not going to be able to charge it.
Then
You're
it'll
probably not
isolate the
going to be able to
pack,
even,
like you were talking
yeah, you're
about.
not going to be able to unlock the door unless you still have a, manual
Oh
key.
no,
Right. It's
that's bad.
yeah, it is. It's really bad. So it's essentially what happens when an electric car like bricks itself. A lot of times it's because the BMS has detected a fault so critical that it is not allowing anything to run off the battery pack. And so for a little while, you'll have your 12-volt system and your 12-volt battery that can keep some of your, like your door locks running for at least a bit. But ultimately, that 12-volt has to charge off of your high voltage pack. Then if that BMS is saying no, you cannot charge off me, you're running on borrowed time at that point.
Another area of technology that pops up now and again is the idea of pack swapping. What do you think about pack swapping specifically as it pertains to a BMS system and how that can be maintained?
So as in like a whole pack swap, instead of fast charging or something like that.
Yeah. So for OEMs, that's something that comes up every now and again as like a tempting thing that, oh, this deals with the charging time. But
Right.
in motorsport, there is some applications like the Datsun that we race is a battery swap situation. That's the only way we can run it for 24 hours straight. And so I expect that until battery technology gets better, there are going to be some applications for pack swapping. I'm not sure I'm convinced on the OEM side, but maybe the specialist application. But just kind of generally curious on what additional complications a pack swap adds from a battery management side, because we even see that in like lawnmowers and weed eaters. You swap
Right.
your battery.
Yeah, so the simple answer to that is that it really doesn't change all that much. And same thing for your lawnmower battery or your whatever, electric power tool, electric saw or drill battery is that the battery management equipment is stored within the battery. And so the rest of the device or for an EV, the rest of the vehicle just needs to pull that data from the BMS within the battery pack. And so when you swap the pack, it'll just be pulling new data, and that new data it can do with it, just as it would with the old pack. So it's not really usually a huge complication from the battery side because it's so contained, or from the vehicle side because it's so contained within the battery.
Is there like a handshake that has to happen so that the vehicle understands that it is a new battery with a new IDs, or is it just smart enough to know that like it may be a new battery, but like it's giving the right signals, so I'm okay with
Right.
it?
Yeah. So that's really that hard to give a one size fits all answer for that one because
Okay.
it varies so much. Depending on how the OEM would implement it. I think because no OEMs have really scaled pack swaps up because it doesn't really make sense for for most applications. We haven't really seen what like the general process would be, but I would suspect that it would probably be something that there would be, yeah, like you said, a different identifier for the pack, and so that would trigger your vehicle to refresh some of your core parameters, like maybe your maximum range at full charge. Because if your new pack is more degraded than the old pack, or vice versa, that value would need to be incremented on the vehicle side. And it also depends on whether or not that data is stored within the battery pack, like within the BMS, or whether it's stored on the vehicle controller, which is not separate from the within the battery enclosure.
Got it. So it's maybe one of those things the OEMs, hopefully, I kind of hope that the OEMs abandon the idea because I don't
Mm,
think it makes good sense from a consumer standpoint. But I do think that we are going to continue to see it in certain areas of motorsport for a while.
for sure. Yeah, I
But
mean, definitely the racing application, any kind of endurance race. I mean, it's the obvious answer. Even like think like an electric NASCAR type scenario. You're burning through power there so quickly that burn through energy that you're going to need to swap a pack, and probably don't want to charge it just because of the time delta of swapping versus charging. And so when you get quick with it, like a pit crew, I'm sure could swap a battery pack in a second and a half or whatever. Whereas charging, you're never going to get to a second and a half charge time. That would be like, you know, thousand C charge rate,
Yeah, that'd be
15 minutes a day.
crazy.
That'd be ridiculous.
I want
So
it.
yeah, no, I mean, I would love it too. I think a good first goal though is at least getting close to parity on gas pump time,
Yeah.
at least for your typical day-to-day driving applications.
Speaking of goals across your portfolio at Vero Electric, do you guys have a backlog of things that you're planning to implement over
Yeah, we
the
always have
horizon?
we've got a big essentially feature list that sits on a spreadsheet and is things that we want to implement on our products. So a couple of those that are coming up, like I was talking about the bidirectional VeroGo stuff. That'll be big because essentially what we're building at this point is like a Tesla app for EV conversions. And so we're hoping to expand what the VeroGo platform can do more and more. Plus, release official apps, so you don't have to go to a website, which is just kind of a convenience thing. And so that'll give you all the controls that you would want effectively out of an OEM car. And for an EV conversion, I think that's pretty neat. And then on the BMS side, yeah, all kinds of stuff, mostly just quality of life things, better debugging. We're working on a settings help update that has little help icons for every settings profile. You just click that, it'll tell you what the setting does in detail, what the limits of it are, like what range you can input. Just again to make life easier for folks using our system.
Those sound like some pretty big enhancements and improvements. What should folks look at for maybe just 2026, like on the nearer horizon?
Well, this stuff should be done before then. Even
Really?
yeah,
Wow.
yeah,
Okay.
yeah. So we try to move pretty quickly. I mean, every time the longest stage is just testing, because anything, even though like for example, the settings help doesn't change the decision logic algorithms on our BMS, anything even adjacent to the main BMS logic has to be vetted super thoroughly because if you screw up with battery management, that's a serious safety concern, and that's not what we're about. So everything gets tested super thoroughly, and that ends up being most of the time commitment. But we tend to move pretty quickly on dev work because we've started out with a lean code base, which as engineers know is a huge plus. We're not working with bloated code, and we try to get rid of anything that's extraneous or unneeded as soon as possible. And we're always looking to essentially shrink the size of the code base without shrinking feature functionality to improve performance and make sure that we're not hitting any unexpected bugs. But so for 2026, I would say like a bit longer horizon. Our next steps is we're just trying to add as many battery types to our system as possible. And so that's both battery modules, which is what we've currently been doing, like the Tesla modules, the Chevy Volt modules, the VW ID3, ID4 modules, BMW i3, but also complete packs is something that we're looking at doing. So like a complete Ford Mustang Mach-E pack, for example. And so the idea with that is that if you can keep the battery pack within its sealed enclosure, you can just have our BMS talk to the original pack controller, which is a little different from what our system does now, in which it basically takes the place of the pack controller. But that allows you to reuse that whole battery pack much more quickly and easily. And especially for like a home battery backup where you don't really care about the form factor as much as for an EV conversion, I think that would be a huge benefit, make it much more compelling.
That's
So that's
interesting. All right. Well, that's a ton to look forward to. Thank you, Ryder, for bringing us through this rapid fire journey through Vero Electric and what you guys have been building and where it's going. I learned a ton, and I look forward to keeping in touch over the immediate future and beyond with everything you guys are doing.
yeah, I appreciate it, Dan. It's been good talking to you.
Sweet.